Well, good afternoon, everybody. My name is Richard Dasher. I direct the U.S. Asia Technology Management Center at Stanford University. We do a lot of public programs too, but today I'm happy to welcome you on behalf of Keizai Silicon Valley. I'm a board member of Keizai Silicon Valley, which actually has been around even longer than our research center at Stanford. More than 30 years, Keizai Silicon Valley has been presenting programs about US-Japan business and about new business trends and opportunities for the Silicon Valley community, all with volunteer effort. All of the personnel who work with Keizai are doing this completely for the good of the cause. So I want to turn over the microphone at this point to the program manager for Keizai for today's program, who is also kind of our master of ceremonies, Ms. Ji-Young Choi of ValueNext. Ji-Young, the floor is yours. Thanks for putting this together.
Thank you. Let me admit more attendees. Okay. Thank you so much for your introduction, Professor Dasher. Hi, my name is Ji-Young Choi. I'm the program manager at Keizai Silicon Valley, and I will be hosting the event tonight. So to give you a brief introduction of myself, I work at ValueNext. If you're not speaking, could you mute yourself? Sorry about that. This is our first attempt to have this Zoom meeting, not the webinar. So there will be some hiccups, but please bear in mind. I'm working at a company called ValueNext, a predictive analytics company providing value by creating insights for innovation through our own big data visualization algorithms. So this is our last series of webinar, harnessing big data through for innovation. So actually, I'd like to share the presentation so that I can explain. Can you see my slide?
Yes.
Okay. Oops. Sorry for the hiccups. This is our last series of webinar, harnessing big data for innovation. So at the last webinar in September, we focus more on digital transformation, how COVID-19 has accelerated digital transformation. So we talk about opportunities and risks associated with digital transformation in the COVID-19 area. So if you missed the last webinar, don't worry, we've recorded the webinar and you can access the last webinar through Keizai's website. So in part 2 of our webinar series today, we'll explore how digital transformation has advanced big data through those digital transformation of paper records or previously inaccessible data points, which enables a new way of collaborate and create new insights. So we have our team of expert panelists to share how organizations are transforming and analyzing big data into innovation and new ideas. So we have amazing 3 panelists, Melanie Carmosino, Director of IP Operations at Microsoft. We have Hiromi Yamaoka, Board Director at Future Corporation. Colin McCubbins, Principal Manager in Advanced Analytics at Walmart Media Group. And our moderator, Sam Wiley from ValueNext, who I recruited for this webinar again. Before we jump into the panel discussion, please allow me to introduce our sponsors who helped us to run this event. Our platinum sponsor is Sunbridge, our co-sponsors, Procopio, Wilson Sonsini, Pegasus Tech Ventures. Silver sponsors, Taza International, ZL Tech. Bronze sponsors, Itoeng, Zetro, Nedo, Provider, Teraoka, TMI Associate, US Asia Venture Partners, JTB. So thank you all for your support. Actually, let me check the participants. There might be people waiting, so please let me allow to admit all of those people waiting outside of this waiting room. So I allowed people to get in. So before we start the panel discussion, actually, when you sign up for the webinar, we ask you some questions. So I'd like to share some of the results to understand those participants and participants' interests. So the first question was, what country do you live in? Actually, we have a lot of people, of course, coming from US, but also 18% Japan, well, 1 person from actually Brazil. That was kind of surprising. Last time we had 1 participant from Australia. So I think it's really good, to have this Zoom meeting, the webinar, so that you can participate from the world. So thank you for participation. Also, the second question was, which one best describe your company? So we have a lot of corporate enterprise attendees, some startup, some government, consulting, law firm, venture capital, and others, some students, I guess. So next question was, which industry do you work in? A lot of software company, manufacturing, legal, financial, government, consulting, and so on. So thank you all for participating. Our next question was, what kind of big data is most interesting to you, to your company for innovation? So 40% said text files and documentation. Thank you. Actually, our company Value Index specialize in text data. So Sam can definitely cover that aspect. Also, the sensor data, I thought that's interesting point. When there's the wild file, actually, I look at this purple, the app show the air quality. So I thought that those sensor data is also very interesting to analyze. Of course, video data, like YouTube data and others, image data, definitely like to analyze those data in the future for the innovation. The next question is, which are the most significant challenges to harness big data? Apparently, most of people think that lack of experience to analyze big data. So expertise, I guess, really is important. Also, constantly evolving use case. There's so many cases that you can build on top of the data. So understanding those new use case might help. Also, keep up with new data source. For us as well, we constantly dealing with new type of data. It's very interesting, but also very challenging. Volume of data, too many manual text, a lot of points. Great point that we can go cover at the panel discussion. So thank you all for participating in the survey. So for today, we will have 35-minute panel discussion, and we'll have 30-minute Q&A in breakout rooms, which means you can have your own breakout rooms. So each panelist will have their own breakout rooms so that we can have more interactive Q&A sessions. So at the breakout rooms, you can definitely turn on your video and also turn on your speaker so that you can have a direct conversation with all the panelists. So that's it from me. So the floor is for you, Sam.
Great. As we did with the last panel, let me share my screen just briefly and go through sort of a fun case study that I had the team here at ValueNext put together for me. Does everyone see my screen? Yes. So we wanted to look at, thinking about this sort of topic today, some interesting types of big data out there, perhaps some things that, wouldn't have been available recently, and maybe the technology really wasn't there to really make use of it. And so something we thought about was Department of Justice data, big data analysis, not just statistics, but some text data that they put out, an analysis of decade of American crime. And what we did was we actually did an analysis using some of our technology here of 13,000 DOJ press releases from 2009, 2018. So kind of a different way of looking at crime statistics or crime analysis, going beyond the numbers that are easily available. And the contents we looked at were the title, the text of the release, the date it was posted, the topics when tags were provided, and components. And we pulled this from a data set called Kaggle. Kaggle's a lot of fun if you love big data and going this. It's just this huge repository of sort of public big data. The technology we use is called a radar. I think that we're obviously very proud of what we do, but there's other ways to do panoramic visuals. We're a big fan of it. However you choose to visualize data, we really evangelize that at ValueNext. But the way ours works is that each of the circles on the screen we're about to see represents a cluster. The size of the cluster represents the number of documents in it, and then the distance represents similarities between them. Axes have no particular meaning. And so when we ran all of these 13,000 press releases through our system, we got some really interesting clusters. We found that there were just kind of these big clusters around tax fraud, very, very sadly around sort of child exploitation and abuse, and then also some interesting areas about voting rights. So it was really interesting to see, not from a statistical analysis, but from analyzing this sort of just big supply of publicly available text data, where there were some real trends in sort of crime and law enforcement and things, various different, state and local governments, law enforcement agencies, even law firms might want to be looking into. And looking at some of those radar trends, there was a lot of really great sort of insights we could pull from it. So federal policy, determining if the crime trends really match where the resources being placed, the statistics, and then these press releases might have some slightly different, takes on where crime seems to be heading. State and local law enforcement could, of course, use this to track national trends. All law enforcement could look at it as a way to, if these are the major areas that are coming up, perhaps we need to train ourselves in how to address child exploitation, or how to address various types of tax fraud. White collar criminal defense law firms might also want to think about how they are training new associates, or what kind of lateral hires they might want to make hires. So kind of another way of visualizing and looking at this sort of text data, all this big data being released into the world. Implications analysis, healthcare fraud, child exploitation, abuse. Something I thought was really funny was the word Alabama kept showing up in the tax fraud cluster. So something's going on with Alabama when it comes to tax fraud. Some growing areas where there's a lot of press releases around the Bureau of Prisons, and other areas of interest for voting rights, ADA. So, just really to give you an idea of how you can go into or a data source like Kaggle and really do some interesting things with big data. So just a very quick case study there. With that, I would like to get the panel started here. If I could stop sharing my screen. I'd like to introduce my panelists one more time. So I've got Melanie Carmesino from Microsoft, a very close friend of mine. Hiromi Yamaoka from the Future Corporation, part of the board of directors, and Colin McCubbins, a principal manager of advanced analytics with the Walmart Media Group. So very excited to have everyone here today. And I think our first topic, let's have everyone go around and talk about their background, give some of their story, and particularly how it relates to big data and perhaps how it applies innovation and other aspects of big data. And Melanie, maybe we'll start with you.
Sure. Yeah, actually, so I'm the director of IP operations at Microsoft, and in my role, I'm responsible for all the technology and tools that our patent attorneys, engineers, conflict and licensing attorneys use, process and data management of all of our data across the various practice groups. So this includes managing the data quality, coordinating the reporting, and coordinating the various dashboards and the technology that provide the analytics around our IP portfolio.
Great. And then Hiromi, how about you go next?
Hi, my name is Hiromi Yamaoka, and I've long been working with the Japanese Central Bank, the Bank of Japan, and as a member of the Basel Committee for Bank Supervision and Director General of the Markets Department, as well as the Payment Department of the Bank of Japan. I was in charge of the duties as a regulator and supervisor of the use of big data by financial industries mainly and fintech. And I was also chairing a couple of international study groups on the usage of big data by financial industries. Thank you.
Great. And then Colin, how about you?
Hi, I'm Colin. I'm at Walmart Media Group. I run our data governance and strategy program. I came from Rakuten Intelligence, where I was a data scientist prior to this, working on sample rebalancing algorithms and things like that. And so I kind of backed into this data governance business accidentally, I think, but it's given me a pretty, I think, unique perspective on what it takes to harness big data now. So.
And I should note that we do have some fun Silicon Valley and Japan connections going on here. Colin, obviously, having worked for a Japanese company, Rakuten, and Hiromi, I believe you went to law school at UC Berkeley. So we
yes,
have some built-in connections here already.
Great, thank you.
So I think our next topic. So Melanie, in your as you mentioned in your role. You've spent the last several years leading a very large digital transformation or DX sort of initiative at Microsoft. And it's been very successful. I think it was also very, very hard at times. But one of the outcomes of that exercise was, you've created a lot of big data. And it can be applied to a lot of things. Could you talk a bit about how that has been harnessed for innovation? And when I say innovation, I both mean, actual innovation for Microsoft itself, but also within your department and other departments that you work with. I think that's also a really important part of sort of the harnessing big data story.
Sure, absolutely. So yes, as you mentioned, we have spent almost 7 years going through a massive transformation of taking a lot of disparate tools and on-prem hosted solutions and pulling those all into one end-to-end solution and focusing a great deal on our data and our data integrity, which I can't emphasize enough is important to anything you do with that data. And we analyze that data every month. And we also have our product, Microsoft Power BI, which is an extremely powerful analytics and dashboarding tool. And so we use that to connect all various data sources, which has allowed us to create some very extensive real-time dashboarding capabilities and really measure across all of our teams. And some examples of that we really dive into are, we look at our patent filings and our idea submissions. We use this data to analyze our outside counsel, bandwidth, compliance, and efficiency. We have much cleaner forecasting abilities and predictability around our budget. We can quickly identify conflicts or agreements that are linked to our patents and information about how we use our patents, which has been particularly helpful in our extensive licensing program. At this point, we have an accurate and full view of our entire IP portfolio. In addition, we've created a patent search tool internally that marries our Microsoft research information, which is not publicly available, as well as all of our data out of our IP management system and any publicly available data from various patent offices around the world, both around our portfolio and competitor portfolios. And that really helps us make some very quick decisions now about where do we want to file? What do we need to abandon when we're reviewing, say, for annuities or allowances? Where do we have gaps in technology coverage and in which various markets? That really helps feed into our strategy plans and lets us build accurate strategy plans. And we're currently evolving that tool to incorporate additional machine learning that will drive further analytics and basically move towards maybe automating some of the decisions we make, which has a positive impact on not only money savings, but on resource time.
No, that's awesome. And I think we'll definitely talk a lot more about the machine learning element later in this conversation. Hiromi or Colin, any sort of thoughts on maybe anything you can relate to, or any commentary on anything that Melanie just might have talked about?
Yeah, thank you. Data is often called as the oil in the 21st century, but data is different from oil in several aspects. First, data never appreciates, and even if it is heavily used. And second, there's no need for a large place for storage. And third, as the data is accumulated, its marginal utility of data may even increase. So it is important that giant IT companies like Microsoft take appropriate measures to protect data security and privacy. So in order to avoid excessive regulation on data usage, it is highly appreciated that big companies like Microsoft take effective measures voluntarily and autonomously. I appreciate it. Thank you very much.
No, that's great.
Yeah, I think there's a large cadre of research, especially coming out of Google, that talks about how like unreasonably effective data is at driving, driving these types of marginal results, insofar as it's usually deemed more effective than modeling. The thing that I constantly see, I think, is like without planning your infrastructure accordingly, so like through some sort of program or institution, you end up with a giant nested web of data that's very hard to traverse, right? And it's really easy, especially I think these types of large corporations where there's a bunch of people working with the same data set, to have, have these like splinter cells of data that kind of crop up everywhere, and you get a lot of duplication, and it makes it difficult to do things like trace lineage. And as Hiromi says, when it comes down to it, it also makes it harder to enforce these types of privacy policies and things like that. So having this in mind from the beginning, I think, is just, it's an important standard to keep.
No, that's great. So I think that actually is a good segue to the next topic. So Hiromi, you have a lot of expertise from your time in banking in financial services and fintech even, but also I think a great overview of sort of the state of big data and harnessing big data in Japan. Could you talk a bit about that and the impact on innovation, but also perhaps as it very specifically relates to the situation in Japan?
Yeah, thank you. Do you see the slide? The slide works well?
Yes.
Okay, great. And big data is now becoming a big issue also in Japan, especially in terms of the Japanese government plan of Society Go 5.0. And especially in the financial services, big data is changing financial industries and financial services in three aspects. First, big data globalizes financial services by using big data. Newcomers such as Alipay or WeChat and Microsoft have entered financial services and drastically increased their users. For example, Tencent in China entered the payment services in just 2013, and its payment services, WeChat Pay, now has over 1 billion users. And second, big data personalized financial services. Big data enables financial service providers to customize or personalize their financial services to each user. Now, many financial services are provided through smartphones, and smartphones are originally very personalized tools. So each person tends to expect that financial services should be customized to himself or herself. And big data enables to satisfy those needs. And third, big data virtualized financial services. For financial services, brick and mortar branches or buildings, ATMs are becoming less important, and big data is becoming more and more important. So for processing big data, financial industries increase the use of cloud computing services. So they do not have to have their own computer devices or computer centers. So in the era of big data, financial services providers use virtual resources such as big data, cloud, and smartphones, apps, instead of physical infrastructure such as branches and ATMs. And big data promote fintech and change the financial services in various aspects. And the first, big data encouraged new players to enter into financial services and diversify financial service providers. Formerly, entities with large branches and networks or ATMs had advantages in financial services, but now entities with big data, the big platform have advantages, great advantages. So many new entities, including big data such as Alipay or Tencent, are entering financial services. And the second, big data changed the structure of financial services. And big data enables cooperation of various entities in order to provide the financial services. For example, in providing payment services, the companies providing hardwares, apps, or collecting customer data and managing risks can be different. But on the other hand, there are a couple of caveats in using big data in financial services and other services. For example, this slide shows the ZMA score, a very popular credit score used in China. and provided by Alipay in China. And if the score is high, there are lots of benefit in living in China, such as borrowing mortgages and renting a car, reserving hotels and restaurants, and going abroad. But on the other hand, if we have a rich friend, our score will go up. But is it a good thing to make friends only with rich people? The usage of big data might sometimes influence the activity of the people, which can be good one or bad one. This is really an ethically difficult issue. And this slide also shows an old map of Bay Area, which I decided a long ago, which was made a long time ago. This map was created a long time ago. But this map virtually shows the composition of the human races and ethnic groups in each location. Of course, this kind of maps are not anymore printed anymore, but analysis of big data may lead to similar results easily if it is badly managed. So in sum, good usage of big data is strongly needed also in Japan. And if we want to maximize the benefit of big data to the society, we need to establish good morale or good standards of usage in terms of big data. This is also a big issue in Japan. Thank you.
No, that's fantastic. And Colin, I know you're going to have a number of things to sort of say about the need to be careful with some of the things that I really like those graphics though. But Melanie or Colin, any initial sort of observations from what Hiromi just presented to us?
I think what he says obviously makes sense. I think big data in the future married with strong AI and machine learning capabilities is going to be the norm in industries from fintech to insurance, contracting, healthcare, and obviously in my nature, IP. I think some of the future uses of this in the IP space are expensive, especially when you get into key search and analysis areas such as licensing and competitor portfolio analysis space. Being able to ingest large amounts of data and having natural language processing capabilities will help fuel the understanding, and the processing will be much more powerful than keywords. Machine and deep learning to understand various languages and technologies and competitive trend analysis and powerful visual comparisons are just some of the things that come to mind. I think the important thing to understand about that technology though is, and it goes back to, resourcing, and one of the surveys that you took of how to manage big data, it's not a plug in and go type of concept. Organizations are going to have to invest in that ongoing learning and updating of their data models to ensure accurate predictions. Not to make a bad joke about our United States elections, but I can see big data in the future helping election polls actually be somewhat accurate. Just had to throw that in there.
Too soon, Melanie, too soon.
I know, but you know me, Sam, it's never too soon.
I was a political scientist, so that kind of hurts.
Well, and but in all truth, I mean, if you think about it, there's a lot of truth to that, though. It can help everywhere, right? If you have the capabilities and the technology. So.
Yeah, I mean, like if you just to riff off that a little bit, I think like if you think about it, a lot of people sort of stick to demography as sort of the input variable to a lot of these types of polling models. Right, and the information space that you're playing with in demographics is just not very large, and most of the value that you get out of these like large data sets are actually the fact that, and I'll talk a little bit about this more, but the fact that every single like slice of data that you put into a model interacts with all of the other slices of data to produce like an exponentially growing space of information. Right, which is why the curse of dimensionality is an issue in machine learning when it comes to overfitting, right? And it's interesting to me to see in industries like fintech where you have a lot of information about people that aren't necessarily related to the product, what types of data interactions you can get out of that can produce sort of learnings about the way that people behave. And the larger your data set is, part of the reason why it's unreasonably effective is because you get a lot more of the behavioral distribution than you would out of like sort of a small sample. And so you do better at predicting the margins, right? Of course, with great power comes great responsibility, as Spider-Man's uncle says. So you also have to be aware of the fact that, you know, when it comes down to it, that information can also be used against either your consumers that you're trying to protect with your privacy policies, or the company as a whole, you know, in the fact that this data can be repurposed to, you know, generate insights or statistics that you might not have seen. I mean, look at the way that Cambridge Analytica, for example, was able to use these small subsections of Facebook's data to create sort of a, you know, a cottage industry or like an enterprise that actually managed to, you know, swing elections.
No, and I think you're already kind of on the topic here, but I saw some of the graphics in Hiromi's presentation that I think really illustrate this sort of the sort of some of the risks of you know, having access to data and what you might want to use it for. And Colin, could you talk a bit about how you know, there's, when you work at a company like Walmart or Microsoft, there's all these really cool things you can do to harness the data. You can make better negotiations, you can design better products, but there's a lot of thought you need to give into this. There's a lot of sort of maybe be careful what you wish for elements to it. And can you talk a bit about some of the thought you've given to that and how in your process for making sure that, you know, there's not unintended consequences and so forth?
Yeah, I think, like, you know, I was sort of on the other side for a long time, where I was trying to get as much value out of the data as I could, and I ended up luckily working with a really great product manager who sort of changed my mind about the sort of the risks associated with having these like high information data sets. So as like a backdrop, I think if you guys are interested in reading something, there's a great little New York Times piece called 12 million phones, one data set, zero privacy, right? And in this piece, I think the Times Privacy Project obtained a file that they got of like 50 billion location pings from phones of over 12 million New Yorkers over a period of several months in between 2016 and 2017. And so once you overlay like all of the pings from someone's phone, you can sort of reconstruct a diary of their life, right? And so think about it like this: like, we're all in this webinar right now, right? And, you know, functionally, if we were all, let's say that we were all in the same building instead of online, you might not be able to tell the difference between us. But then once the webinar is over, we're all going to disperse and go back to our home. That is actually enough to fingerprint every single person in this call, right? Because you're no longer co-located, right? And this is what we would consider like high information, right? Because there's a ton of locations that you can have that are available to you. And so, you know, it's very rare that two people are going to be co-located with each other for eternity, right? And it's even, you know, it's even less probable that that happens for larger and larger subsections of the population, right? And so when you're working specifically, I think, with event level data, which is what most people use in their models, because of course it's like the highest information data that you have available, it's the most performant, you get the most behavioral characteristics out of it. That kind of stuff needs to be tightly controlled, and the way that you have to tightly control it can't just be like writing a policy or something, because you don't solve the problems of the world by putting it just on a piece of paper and leaving it, right? You have to build infrastructure around it, and it takes planning. And I think a lot of that, we're going to see a trend as the world moves more towards this like privacy focus with, you know, like the elimination of third-party cookies, and, you know, Apple got rid of the IDFA identifier, right? You know, all of these, like there was a ballot measure in California that looks like it's going to pass, that's going to increase CCPA's capabilities. You know, a lot of the necessity for these companies is going to shift in focus, I feel, to focus more on like machine learning and risk analysis and stuff like that, using data to understand what the risks are in their data set, so that they can continue to you know, provide these sort of data-centric products without having any sort of leakage or risk associated with it.
No, that's really interesting, and I know some. We I think when we were planning this panel, you had mentioned there were some other interesting things that can happen where some really innocuous data, big data, could be released, and all of a sudden you can sort of know what sort of books and TV shows people have been watching, and really figure out exactly which person you're talking about. So I think that some well-meaning big data gets released, and then some internal well-meaning data also can be used. And I'm sure people like Hiromi and Melanie have given a lot of thought to that. Do you guys have any sort of comments on what Colin just mentioned here in terms of some of the things we need to think about?
Yeah, I think, and obviously Colin, outstanding information. I think, clean and expansive data are necessary to success in this space, whether it's IP or fintech or any other industry. And I think it all rests on the capability of organizations to procure, manage, and expand that data and invest in the time it takes to ensure that those ongoing data models are producing the optimal results, right? The capabilities are endless, but it does require the right level of investments, as Colin said, and the resourcing to be successful. You need to frequently check your assumptions and your inputs. Roles like data scientists are absolutely critical in this space, as is, effective data governance, and privacy expertise and privacy practices are extremely important. And I think when you think of applying machine learning, it also takes a certain degree of, we call it dark arts, to understand and leverage the machine learning models for problem solving that can require a deep understanding of what that system is doing. As an example, an overfit data set can appear to be discriminated under a highly accurate machine learning model, but when applied to another data set, that model can fail miserably. So.
Thank you. I really agree. And I'm a Japanese and I'm an Asian. But even though I do not declare that I'm an Asian, it's easy to detect by using a big data. If they understand that I eat rice 5 times a week and I play golf 2 times a week. So, and then usage of big data is quite important to enhance the transparency of using big data and clarify the purpose of using big data. And there's lots of issues such as data security, privacy, and cyber resilience, and the ethical issues, and which will require more and more attention to the relevant people. So it will be needed for the organization to pay attention to these issues. Thank you very much.
No, that's great. And I think these all segue into the next topic, which is something we've heard a lot about today, which is there's a lot of excitement around the application of AI and machine learning to big data. There's no way any organization has the human manpower, person power, I should say, to go through big data in a meaningful way. But to Melanie, I think Melanie's mentioned this a couple of times, Colin's probably mentioned it as well. The technology really isn't quite there. There's dark arts, as Melanie likes to say, involved. Maybe I'll just throw out to the whole panel, but where do you see ML AI really playing a role in big data in the near future, and then maybe medium future? We know in the far future we've got a lot to look forward to, but close to home, where are we right now?
I can take that from a Microsoft perspective. As I said, we're very focused on harnessing big data across our entire organization. HR, immigration, contracts, overall operations, finance, and in IP. And, we have a data science organization that's specifically focused on these areas across our whole legal affairs division, and working to create and manage ongoing data models that incorporate changes and learnings. Specifically in IP, I think we can see in the near-term future, AI can, again, to a certain extent it does, but it can further impact idea harvesting and, again, portfolio gaps, identifying market opportunities in key countries and predicting where you can be successful in those countries before making an investment. Not everybody has the deep pockets that Microsoft does. I can see it, suggesting claim language and furthering patent drafting capabilities. And again, those exist to a certain extent, but they can certainly be improved. I think obviously searching capabilities come to mind, but taking that further into machine learning to understand, the various technologies and competitive analysis based on those insights and financial predictions based on trends. And I can even see it in the near future impacting things like docketing and administrative portfolio management tasks that can help eliminate the human error. An interesting statistic I read at WIPO is that they estimate that 25% of the patent data that people have is incorrect. So, I think in the near future, you can see a strong impact in those spaces around intellectual property.
Hello, and I'd like to focus on the near future and in the financial services. And AI and machine learning are now used by many areas, financial areas, including especially the credit risk management. as a Zima score, which I explained. For example, big platforms now in, for example, the Mercado in Latin America collect a lot of data on people's usage of e-commerce, for example. And they track the movement of inventories and make a credit risk assessment by using SNS or payment records of the companies and the personal persons. They could detect the credit risks by using big data and make use of this data for the loans, giving credit, many aspects. And in the near future, AI and machine learning will be more widely used for decision-making itself. And for example, decision-making of investment, including purchase and sales of financial assets, are more widely dealt with by AI and machine learning. And accordingly, it will become more important to clarify the legal aspect of AI and machine learning based on decision-making made by AI. And for example, is a contract, if a contract is made by the decision of the AI and not by human beings, it is enforceable or not. And if the losses or damage is caused by the decision of the AI, who should be liable for those losses or damage? And there will still be many issues on the legal front. Thank you.
No, that's super interesting because we've already seen that to smaller extent with situations where a runaway automatic program at a stock brokerage generated losses and trying to unwind those and so forth. You can imagine if it was an actual computer program, or AI running those, it might be a lot harder to unwind. So that's definitely something to think about. And Colin, what about your thoughts on this area?
I think so. I think Melanie, especially, I think covered like pretty much everything under the sun, which is interesting and I think true. And like, there's a lot more machine learning that's sort of cropping up to, monitor internal performance, which, it used to be like very expensive. And so I think a lot more machine learning was focused on trying to harness the power to like power some sort of product, right? So I'm going to take a slightly tangential stance and maybe not answer the question, but like I think one of the things that I think you're going to end up seeing as data becomes a little bit more expensive while machine learning becomes a little bit less expensive. Right. And by data becoming more expensive, I mean, it's going to be harder to get all of these like very large scoped data sets with all of these privacy restrictions that are coming is more of a focus. I think like machine learning, I think we have to move past the days where we just shove everything into a giant model and sort of let the machine decide what's going on, what the data is telling you, and instead be a lot more focused on like the experimental design principles behind, like feature creation, hyperparameter tuning, stuff like that, that really like get the marginal results out of the machine, because the machine is going to be really good at finding what the average case is, right? And so it's really good at monitoring, right? And covering more and more of the use cases out of the machine requires a little bit more. It's always going to require more of a human touch, right? And so there has to be like a larger focus on programs that have people designing research around what the machine is capable of, instead of using the machine necessarily to decide what all of the research is that it should be looking at itself, right? And that takes a little bit more of the black boxiness out of it, right? If you're thinking very, if you're being very hypothesis driven about the outcome that you're seeking, the business outcome that you're seeking, it's a little bit easier to interpret the output of these like giant neural nets that have, a lot of nested layers inside of them.
Got it. No, and I think that's that's kind of been a very frequent topic, right? Is that there's I think that the easiest way to put it is the garbage in, garbage out, right? It's if people are being very thoughtful about how they prepare the program and what they're trying to achieve, I think you're more likely to have a successful outcome than just sort of setting loose, just saying there's so much data here. Surely there's got to be some gold in there somewhere. Let's just brute force it. So I think that's a incredibly important observation. Know we're getting towards the end of our time for the panel, but I do want to end on one last question for everyone. So everybody here has been involved in a DX of some sort. And or knows a lot about it or has observed them. And I was curious, for organizations very early in their journey, do you have any recommendations how you set that up? What's the best way to get started so that you do have the opportunity to create a lot of value from the data that's generated from a digital transformation process? Any advice for organizations that are early in the process?
Hire a lot of data engineers
I can
right
start
now.
with that. I mean, yeah.
Sorry.
Yes.
Yeah, I would say that's very true. I mean, I think you have to look at it's because big data requires big compute, strong governance practices, and again, the correct skill sets. And my advice to everyone right now, I realize that times are very challenging and spending is retracting in organizations as a result of COVID and its global economic impact. But you really got to look at the long game in the future. And I think this current remote world is going to force this need even more. I think a lot of companies, including Microsoft, we're shifting to a 50% from home is the normal way. And so you need to make this investment in your DX journey to ensure your long-term success. And it's critical to the business being able to move at a rapid pace and to be agile. And one interesting statistic I read, I think it was a couple of years ago, so I'm sure it's outdated, is that the amount of data produced in the last decade is 9 times the amount of data produced ever. And so, if you don't get a handle on this sooner rather than later, it can become insurmountable. And so again, between the technology you use and the skill sets of those you employ to manage that data, it's really important to get moving on that and moving fast now.
So I'd raise 3 points. And first, to clarify the purpose of using the data and the value we want to create by DX. And data itself is a neutral one, and it will be necessary to cleanse the data before it's used. So the important thing is not to use the data itself, but to create the value of using the data. And the second, the tasks are not limited to the usage of data and data processing. If we want to use data and promote DX, we need to review overall business procedures and practices in order to make most efficient use of data. For example, under the COVID-19, this year, Japanese government tried to provide a financial support to Japanese citizens, all the Japanese citizens, but the government could not provide them through digital measures. They tend to rely on manual procedures for providing the support. So there remains lots of paperwork and manual procedures in Japan. That is the heaviest problem now. So if we want to utilize data to promote DX, we need to create effective ecosystem that can maximize the benefit of using data. And to pay attention to data security and cyber resilience and ethical issues in using data. So if a problem or criticism happens regarding the usage of data, the DX will be substantially hindered. Thank you very much.
No, that's fantastic. And I think we have a comment from the audience. Colin, honest machine learning is good and great. There are many manipulation of data. I think, Colin, I think everyone's pretty excited to pick your brain on, I know I am, I know Melanie is. So you please plan to get some emails from people after this conversation is over. And then we have a comment from Jen Cart, Microsoft, that we, in addition to data scientists, we need project managers. And I think that is absolutely true.
Yeah, I think it, I know I just like randomly blurted that out, so I'm sorry. But I think like, to be honest, I see when I was when I was more involved in the like actual data science side of this, I saw a lot of like young companies would ping me to come in and interview, and I look at, and they haven't like planned around their data at all. Right, they don't have any infrastructure. Nobody's like trying to actually build any data warehouses, and so you get like a data scientist in there. They're expensive, right? They're looking to build a model. They don't usually have, unless they're a super unicorn like me, wink wink. They don't usually have the ability to like do all of that data transformation that you need. So they have to pick it up. They're not going to be as good as someone that, specializes in that area. right? And so a lot of what you were looking for out of that data scientist becomes a lot more, it becomes a lot more challenging for them to work, and they spend most of their time cleaning up the data. And unless you have, like, it's really hard to work through the digital transformation backwards, right? And so if you let it get to the state where, because you haven't planned and because you didn't hire the right type of person who has that like strategic mindset about what that data is going to be used for, you have the wrong KPIs, which happens all the time. Like, let's say that you're trying to drive sales and only sales, you end up in that world where you're just chasing the next dollar because the organization is pivoted entirely in that direction. And you never go back and clean up the data. You never go back and develop that strategic mindset. So you have to do it on the fly. And that's so much harder and much more expensive. And it interrupts the entire business. Every time that you want to turn the crank on something, some analyst has to sit there and wait for 2 days for their SQL query to finish. And everyone just, all of the work gets gummed up, and it's impossible to create a new data product.
And Colin, before we break for the Q&A rooms, we do have a question for you about, do you have any recommendations on how you prevent that sort of manipulation of the data? How do you proactively, keep it safe?
Yeah, I'm assuming from a privacy lens. I think the strategy that we took, the strategy that I promoted at Walmart Media Group, I think was, you need to be careful, one, about the data that you're giving out in conjunction with other data. So people, I think, are too used to thinking about like one column of data, like, oh, we need to encrypt this PII, right? And encryption, encryption can be broken, one. But two, if you're giving away too many statistics, I think, there's a paper out there about the what they call the database reconstruction theorem, and it actually caused the census this year to revise its entire program to include some sort of differential privacy measure, which randomly jitters data that goes into an official statistic. But you get a lot of information out of having 2 statistics instead of 1. Right. And to put it simply, like one thing that happens for us all the time is we have to give out information about, the number of purchasers who purchase some sort of item and the average order value. And if you get those 2 things, you can back into sales information. And then all of a sudden, like, you have some maybe material non-public information that should not be going out the door. Right. So you have like this is maybe not as much of a like an answer to this question because it's a little bit nebulous, but like I think you need to pay attention to stuff like that, like what other data and insights are available to the recipients. What can they get? What are they getting from you guys? What are they getting publicly? Are they getting something from somewhere else in the organization? What is the minimum number of people that you're willing to give a statistic about? What is the granularity, either the channel or business unit? Like, should you publish sample sizes? How rare or how much information is contained in a particular insight or piece of data? To name a few things, I think like are things that I would keep in mind when you're trying to prevent that type of manipulation from happening.
No, that's fantastic. Great answers and a great panel. I want to thank everybody for participating. Obviously, we've got some really brilliant panelists here today, experts that we've all learned a lot from. And I think there's going to be some really great questions in the Q&A section. So we are going to break into private rooms. This is a first time for me, and I think a first time for a lot of people using this format. So please be patient with us. And I'm going to hand it over back to Jiyoung, who will, I think, divvy us up into our Q&A sessions.
Yes, so I will separate the rooms based on your wishes, your preference. But just bear in mind, if you're in the wrong room, don't freak out. You can just text me. I will try my best to change the rooms. So we'll have a Q&A session until maybe 6:15, and maybe we can come back to this main room and wrap it up. So I will break the room now and enjoy your Q&A sessions.
Oh, I see. We were early.
Yes,
Yeah.
Yeah, Zoom
Now I
has
get the
this.
message from Ji-Young
Yeah.
saying she's going to shut down the breakout rooms. Sorry about that.
Zoom has this great feature like that you can set. I don't know how to use it, but I joined some weekly Zoom calls and
Yeah.
you can automate the breakout, who gets in what room, and then set a
Yeah.
timer and it'll automatically bring everybody back together. And it's got some pretty cool features. I have to say I have learned to like Zoom for these
Yeah,
kinds of things.
they've got some things that they do pretty well. But that's going to be a very tough competitive space.
Yes, yeah. Well, we love Teams. Don't get me wrong.
I was
Teams
about to
is
say, I can imagine.
Teams is still our to our heart, but Zoom definitely has some features that that are very interesting and helpful in these kinds of sessions.
Well, I think
have
the room is assembling again. So
Yeah, here we go. I was just going to make a joke that I've sent Jen and Melanie a number of Zoom and Google Meeting requests that get denied, and I immediately get a Teams request in response.
Well, I have to plug Teams because we have much better privacy practices than Zoom.
That's right. Security and privacy are much better.
I'm just saying. And yes, Microsoft won't even let me start a Google meeting on my computer. So that's just a big no-no. It just won't even open.
Great. I guess everyone enjoyed the breakout rooms, the more interactive Q&A sessions. So I'm glad to see everyone showing up the face. So thank you so much.
Thank you.
Thank you. So I will just share the last slide. So I know, we want to continue the discussion. So if you feel like reaching out to the panelists, here is the contact information. So please feel free to reach out to them if you have any further questions. For today, this is it. The last series of our webinar related to digital transformation and big data. So I hope you enjoy. Thank you so much. Thank
congratulations to you.
Thank you.
Yep. Thank you.
Thank you.
Great program.
Well done.
Thanks
Good session.
everybody.
Yeah. Thank you. Bye.
Thank you.
Bye.
Bye.
Jimmy さん、それ